Next, let's do an exercise. You see, it's a motor, which is powered by a AC with 220 volts RMS and 50 Hz. The power rating of the motor is 1000 watts, and the power factor is 0.8 lag. In addition, a capacitor is parallel to the motor. The capacitance is 30 microfarads. We need to find the power factor of the whole circuit. That is the power factor of the dashed part looked to the right from the power supply. Then how to solve the problem? According to the introduction in lecture 64, we assume that U is 220 with 0 degree. Here, an initial phase angle is given. As long as we calculate I, we can know the power factor of the circuit. In order to solve I, we need to use KCL here. So we need to solve ID and IC respectively. For a motor, according to the definition of the average power, we know that the power is 1000, the voltage is 220, and the power factor is 0.8. We know that the effective value of the current is 5.68 ampere. In addition, because it's a lagging power factor, we know that combining these two, we can write the phasor of ID. The minus sign here because we assume that the voltage angle is 0. So only the current of minus 36.9 can ensure that the voltage leads current 36.9. That is meaning the current lags voltage. It only need to apply Ohm's law for capacitors. That is, we can use KCL to get it. So we know that the initial phase angle of the main branch current is minus 16.3 degrees. So the power factor of the whole circuit is Then we finish the solution of the problem. Before continuing in the next part, we might as well do a little analysis. You see, without a capacitor, the power factor of the motor is 0.8 lag. After adding a capacitor, the power factor of the whole circuit changes into 0.96 lag. After we add a capacitor, the power factor seen from the power supply changed from 0.8 to 0.96. What's the actual meaning of that? We will give the answer in the next lecture. Then let's talk about the measurement of the average power or active power. We know that the voltmeter only needs 2 terminals to measure the voltage across the terminals. The ammeter also needs 2 terminals to measure the current flowing through the 2 terminals. But for the power, P equals Ui cosine phi, where phi equals psi u minus psi I. So we need 4 terminals at least, 2 terminals for measuring voltage and 2 for measuring current. You see, the voltmeter is a 4-terminal device, where 2 terminals are used to measure the current. That is to say, we define the current measuring from start to another terminal is I. 2 terminals are used to measure the voltage. That is to say, we define the voltage measured from the angle to another terminal is U. There are many kinds of implementations for the voltmeter. Here we will not introduce them in detail. You only need to know after measured U and I, the voltmeter can give the value of Ui cosine psi u minus psi I. We need to emphasize that any meter has its range. We know that the voltage we want to measure should be less than the range of the voltmeter. The current meter is also similar. For voltmeter, it needs to meet that voltage, current, and power should all be less than their ranges. Then we have a look how to use a voltmeter to measure average power absorbed by the load. We need to measure the load voltage and also need to measure the current flowing through the load. So we connect the star and another terminal of the voltmeter to the main circuit of the load according to the direction of the current. That's like this. Then how do we connect the voltage terminals of the voltmeter? We need to measure the voltage across the load. That is, one terminal connects to here, and the other one connects here. You see? From the angle to another terminal, we can measure the voltage across the load. So the reading of the voltmeter is the power absorbed by the load. Here we give you a question. If we want to measure the active power supplied by the load, how to connect the voltmeter? It should be pointed out that a marked star and angle here in order to differentiate ports used to measure the current and the voltage. In practice, if the connection mode of the two ports are obvious, then they can be marked into star or angle at the same time. Well, we do another exercise. We assume that the frequency of the power supply is 50 Hz. We know that the reading of the voltmeter is 50 volts, the reading of the ampere is 1 ampere, and the reading of the voltmeter is 30 watts. We use voltmeter, ampere, and voltmeter to measure such a coil. R and L are the element parameters of the coil. Now we need to find the resistance and the inductance. For the problem, we can calculate by definition of the average power, that is P equals Ui cosine phi. We know that P equals 30, U equals 50, and I equals 1. So we can get cosine phi equals 0.6. And we also know that it is an inductive load, so it's a lagging power factor. Next, by using Ohm's law on the load, we can know that the modulus of Z is equal to the ratio of the effective value of U and I, so it equals to 50 ohm. We draw the impedance triangle. We know the modulus is 50 and the cosine phi is equal to 0.6. It's easy to know that the resistance is 30 ohm and the reactance is 40 ohm. We also know that X equals omega L. Substituted F equals 50 Hz into it, then we know that the inductance is 0.127 Henry. That's the analysis of the whole circuit is completed.